Unit 3 students, today I'm going to show you how you can use zeros that you've been given to help you find the other zeros of the polynomial function. So far we've learned that if the function has an x-intercept, say at -7, you know it's going to have a factor of x plus 7, right? And one thing we know about factors is that if something's a factor of something, it divides nicely into it. So like, for example, if you do 20 divided by 2, you get 10, right? And that's because 2 is a factor of 20. Now, if you do 20 divided by 3, right, you're going to get, 6 remainder 2. You get a remainder. If you do it on your calculator, you're going to get a decimal. And you know that, if I told you what are the factors of 20 or what multiplies to give you 20, 3 wouldn't be in that category because it doesn't divide nicely into it, right? So the same kind of applies with factors of polynomials. If something is a factor, it's going to divide nicely into it without any remainders. So we can use this idea to take the factors that we know work with the polynomial, divide it into there, and kind of bring the polynomial down to a lesser degree so that we can either use quadratic formula or just simply solve for x and get those more challenging zeros that are more difficult to find. All right. Now, you might be like, well, can't we just look and see the zeros here? Well, do you see how it doesn't go through very nicely at -3 and 3? It's a decimal that it goes through. So we can't just look at it and know what decimal it goes through. So we have to do the math for it. So if we know that x plus 7 is a factor, we can do this polynomial divided by x plus 7. And we know from synthetic, we switch the sign from our binomial here. So we're going to do a -7. And we take our leading coefficients, or I should just say coefficients in general. We get 1, 7, -8, and -56. We're going to go ahead and do our synthetic. 0, -8, +56. All right. So our resulting polynomial here is going to be x squared plus 0x minus 8, which we would write as x squared minus 8. Okay, so what this means is I can multiply x plus 7 by x squared minus 8 to get back to my original polynomial here. And that makes sense, right? If you think about it, when I do 20 divided by 2, I get 10. Well, if I do 2 times 10, I get back where I started. So that's what we're doing. We're going to do x plus 7 times x squared minus 8. All right. Now, at this point, you would check to see if you can either factor this further, if there's any way that you can further break any of these down. At this point, you cannot. It looks like it might be a difference of squares, right? Because you can square root that, you've got a minus sign, but you can't take the square root of 8. So this is not a difference of squares, so we can't just, nicely do that. So at this point, we've factored it completely. And once you've factored your polynomial completely, you can find all of the zeros by setting the zeros equal to 0. Setting the factors equal to 0. All right. So we're going to say x plus 7 equals 0 and x squared minus 8 equals 0. We subtract 7 from both sides and we get x equals -7. We're going to add 8 to both sides and we get that x squared equals 8. Now, to solve for x in this scenario, we have to take the square root of both sides to undo the square. Now, the rule is when you add in a square root symbol, you need to add in plus minus. All right, so we end up with x equals plus minus the square root of 8. This we could actually break down. 8 gets broken down into 4 times 2. The square root of 4 is 2. So we end up with plus minus 2 root 2, because that 4 comes out and becomes a 2. So at this point, we found all of our zeros, all right? Our zeros are the -7 that we knew already. Then we got 2 root 2 and -2 root 2, all right? Now, if we look back at this graph, we can see that it went through these gross decimals. Well, if we go to a calculator and we plug in 2 root 2, we get 2.828, right? And if I do -2 root 2, we're going to get -2.828. okay? And if we look at the graph, you can see, yeah, it goes through about 2.8 and about negative 2.8, which obviously we wouldn't have been able to get this answer just from looking at it, but we were able to calculate exactly what it was. All right, now let's move on to this next one here. All right, now I guess one thing I want to also preface is if you looked at number 1, you may have been tempted to go and factor by grouping, which 100% you could have gotten to this point by factoring by grouping. If you decided to go that route, you technically don't even need this graph to solve this problem. So if you looked at this and you were like, I want to factor, 100% go do that. You'll get the exact same answer. And honestly, it probably would be a little bit quicker. However, if you look at number 2, if you remember from our flow chart, right, we know how to factor things with 4 terms, but we don't have a way to factor things with 5 terms. And this guy here has 5 terms, so we have to make sure that we use these roots that they give us here. So let's go ahead. We can see that x plus 4 is going to be a factor, and we can see that x plus 2 is going to be a factor. So what we're going to do is we're going to divide those into this polynomial one at a time. The order that you divide them in doesn't matter. If you want to start with the 4, if you want to start with the 2, it does not matter. So I'll go ahead. I'm going to start with the x plus 4. All right. So when I do take my polynomial and I divide it by x plus 4, I put a minus 4. I get 1, 6, 17, 54, and 72. I drag my 1 down, negative 4, 2, negative 8, 9, minus 36, and then let's see, 54 minus 36 gives me 18. And 18 times negative 4 is going to give me a negative 72, which, again, I should be getting no remainder. If I'm saying that this is a factor, right, when I do my synthetic division, I shouldn't be getting a remainder because factors don't give you remainders. All right, so now at this point, our resulting polynomial is x cubed plus 2x squared plus 9x plus 18 times, and then x plus 4. So we can then look at this. You could go and try and factor this by grouping if you want to at this point. Or since we have a graph, you can divide the other root that we have into it. Either method, in this case, is actually going to work. There will be scenarios where factoring by grouping, doesn't work. And that's going to be in, you're going to see that shortly. We have to use the quadratic formula when that happens. But this one, if you want to do factoring by grouping, you could if you wanted to. But I'm going to show the way using synthetic just because we're kind of practicing that. But do know that there's more than one way to solve this. And it's not like one way is better than the other. I just want to make sure I show you all different ways. So we multiply, we get a negative 2, 0, 0, 9, negative 18, 0. So we end up with, so remember we started with a power of 3. So this is going to be like power of 2, 0x plus 9. So at this point, we've got x plus 4, x plus 2, right, because we divided this guy by the factor x plus 2. And then we've got x squared plus 9. That came from this. All right. So if I were to go and actually like FOIL all this out, I should get back what I started with, get it back into standard form. We're not going to do that because it's not going to help us in any way, shape, or form. So at this point, we look, okay, can we factor this guy anymore? He's not a difference of squares, right, because he doesn't have that minus sign, so we can't factor him anymore. So at this point, we can just go ahead and set these equal to 0, okay? So we get x plus 4 equals 0, x plus 2 equals 0, and x squared plus 9 equals 0, all right? So we end up with x equals negative 4, x equals negative 2, and we get x squared equals negative 9, which then we have to take the square root of both sides and add in a plus minus. So we get x equals plus minus the square root of negative 9, which that turns into 3i. So for this one, our zeros are going to be negative 4, negative 2, 3i, and negative 3i. All right? All right. So up until problem 6, they're all going to be done very similarly. Okay? Now let's go ahead and take a look here at number 7. All right? Oh, actually, I guess one thing I do want to point out is, it makes sense that we got 2 imaginary solutions here. because if you look, there's no other x-intercepts on this graph, right? And this is a power of 4, which means that we could have had up to 4 zeros. But we ended up with 2 real zeros and then 2 imaginary zeros. So that's where the 4 zeros go to. All right, so here, instead of giving us a graph, they just straight up gave us a 0. So if -5 is a 0, that means that x plus 5 is a factor. All right, so we should be able to nicely divide that into this polynomial, okay? So we get a -5, we get 1, -4, -43, and 10. All right, so we go ahead, do our synthetic. 1, -5, -9, 45, 2, and -10. So at this point, we have x squared minus 9x plus 2 times the x plus 5 that we just divided in. So again, if I were to multiply this back out, I would end up with this. Now, our goal is to essentially fully factor, and once everything's fully factored, that's when we set the factors equal to 0. Now, you could look and say, okay, can I factor this guy any further, right? In this case, it'd be one of those easy ones where, like, what multiplies to 2 and adds to -9? Nothing works there. You simply cannot factor it. So when we go and set these equal to 0, here, I'm going to change up the order just so I have more space for the other guy. From the x plus 5, we get a -5, which makes sense. And then here, if you remember from last year, Math 2, when we have a quadratic that we can't factor, we're struggling to solve, what we can do is solve it by using the quadratic formula. So the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2 times a. So make sure you copy that down. You're going to have to memorize that. So we can look, all right, well, our a value is 1, our b value is -9, and our c value is 2. So we're going to go plug that into a quadratic formula. It's opposite of b, so we get 9, plus or minus the square root of b squared. So we get 9 squared. Remember to use parentheses whenever you plug in a negative. Minus 4 times a times c, all over 2 times a. Now, a lot of kids are tempted to just plug this entire thing into your calculator, but we're going to want, like, simplified answers. So the way that you do that is you have to plug in, like, what's inside of the radical first to figure out what number's, like, in there, and then kind of break it down from there. If you just plug it into your calculator, you will get a decimal, so you won't be able to get an exact answer. So we have square root of, we have -9 squared minus 4 times 1 times 2. We get a 73. So now, we have 9, oh my gosh, stop it. 9 plus or minus the square root of 73 all over 2. Now at this point, you check to see, okay, can I break this radical down? This is where you would try perfect squares. So, you would try all the perfect squares less than 73. So you could start at what, 64, 49, 36, and just work your way down to see if any perfect squares go into that to see if you can simplify it. Unfortunately, you can't simplify it, so this actually is just our final answer here. All right. There is 2 ways you could write your answers as well. If you recall, with imaginary numbers, we split it into 2 fractions and then simplified if we could. Now this one doesn't simplify at all, so 2 acceptable answers would be like this or that. So then I guess our final answer here, when it's asking for the zeros given, you would do -5 and then either give, one format of these. I'll just give the first one that we were using. We have 9 plus root 73 over 2 and 9 minus root 73 over 2. And these would be all of our zeros. And again, this makes sense. We have a highest power of 3, which means that we have 3 possible zeros, and we found them all. All right, I'm going to look real quick because I want to make sure we do one that simplifies a little bit. All right, let's go do number 10. All right. So again, we have our 0. We know that x minus 3 is a factor. We're going to go ahead and divide that into here. Remember, you switch the sign. 1, 5, -31, and 21. We drag this down. 3, 8, 24, -7, -21, 0, which again, That's a good thing because we shouldn't be getting a remainder. So at this point, we factored it to being x minus 3 times x squared plus 8x minus 7. All right. Of course, you could look and see, okay, well, can I factor this, right? Are there two numbers that multiply to negative 7 and add to 8? Well, to multiply to negative 7, we need we'd need like a negative 1 and a positive 7, or a positive 1 and a negative 7, which is going to add to either 6 or negative 6. So there is no way to factor this. So once again, we are going to be stuck with quadratic formula. So we do x minus 3 equals 0. We get x equals 3. That's one of our zeros, which makes sense. Then we've got x squared plus 8x minus 7 equals 0. We got to use quadratic formula. A equals 1, b equals 8, c equals negative 7. So we do opposite of b, plus or minus the square root of b squared minus 4ac, all over 2 times a. We can go to our calculator, plug in what's inside of the radical. So you're just going to plug in this, not including the radical itself, just what number is going to be inside of there so that we can simplify it if needed. So we get 64 minus 4 times 1 times negative 7. And I got a 92 in there. So I've got negative 8. Oh, stop doing that. Plus or minus the square root of 92 all over 2. Now at this point, you got to check to see if any perfect squares go into 92. I believe 4 is the biggest one. Yep. So you're going to break that 92, oh my gosh, stop writing in highlighter, root 92 down into 4 times 23, which gives you 2 root 23. So instead of root 92, we're going to put 2 root 23. So we've got negative 8 plus or minus 2 root 23 all over 2. So at this point, there's two different ways to simplify. One way is the 3 friends method, right? You heart these 3 guys here. You do not include him. He's not part of the group. And you find the biggest number that you can divide all of these by. 8, 2, and 2 can all be divided by 2, which is going to give us a negative 4 plus or minus, and then 1 root 23, which we just put as root 23, all over 1, which with fractions, you don't put them over 1. So that is your answer from that method. The other method is splitting it into 2 fractions like we did with the complex numbers, which gives us the exact same answer of negative 4 plus or minus root 23. Root 23. All right, 2 different methods to simplifying there. So our final answer is going to be, and I'm kind of running out of space, sorry, 3, negative 4 plus root 23, negative 4 minus root 23.